create an abstract class in Kotlin, all you're going to do is slap the abstract keyword right on the class itself. Now you have an abstract class. Let's go ahead and delete that though, and back at the main file and see how this impacts it. By default, classes are open, so we can go ahead and create instances of them in Kotlin. So now I have a vehicle. If I want to provide the color, which will be red, and I can create many different vehicles. So I create, call this one A, this will be, blue, and I can create many more, etc. However, if I want this to be abstract, all I have to do is add the abstract keyword, which is a modifier to the class. Now, I am not allowed to create an instance of an abstract class. Now you may be wondering, why would you not want to create an instance of an abstract class? Well, if you think about it, when we're designing type systems, we have various different types we're trying to represent. In this case, we might be building an application which works with vehicles, but we do not want users of our application to create just a vehicle instance. We want them to create actual implementations of a car and a truck and so forth. And so a lot of these vehicles will have some similar things to them. For example, they may all have a color. They all may have a number of wheels. So we say val, number of wheels. They may all have various different things and doors and so forth that are all similar. So we can say number of doors as well. So val, number of doors. Now, for whatever reason, this vehicle may actually drive a certain way. So it may need to shift gears a certain way. So it may be an automatic, it might be a manual, different type of vehicle. And we may not know what that is. So we might want to actually have, if we, for example, was to provide a method to tell the vehicle how to drive. And so that function might be just be called drive. Now, this perhaps does something. Well, now depending upon the vehicle, drive can mean one thing or another. For example, in a car that's an automatic, we just step on the accelerator. As long as we're in the drive position, it drives. However, if you're in a manual transmission environment where you have to shift gears manually, well, drive is going to require a few more steps. So we cannot abstract all this information into just this class here, into abstract. So this class, we might want to actually say abstract function drive. Now I'm not going to provide an implementation here because the implementation is going to change based upon each different implementation of the class. Now, one thing that may be the same as everything else is a function called open door. And this function just simply opens the door. And all that does is open the door. Now it's going to be the same perhaps for every single vehicle you have. You pull on the handle and the door opens. Now, of course, this is different if in the real world we're going to have electric cars and electric doors and electronic doors and manual doors. But for the brevity and situation here, perhaps just assume that every door is open the same way. And so we can leave that inside of our class here. It's an abstract class. We can start having other different things inside of here, such as a function called stop. Well, what does stop do? It just stops the car. And maybe even better, say turn off. Even better, every car can be turned off, vehicle can be turned off. Let's just turn off the ignition. And if we want to be real specific, say turn off ignition. And perhaps this is going to turn off the ignition, whatever that implementation looks like is what it looks like. However, we now have an abstract class that does a couple of things for us that we don't have to re-implement everywhere else. And this is the vehicle class. This is how we can define an abstract class, but we cannot implement it. So we actually have to implement it in another class somehow. But so we can have a function that's abstract, which means, hey, whoever is going to extend this vehicle class at that point has to also implement this drive method because it's going to differ between different classes. However, they can go ahead and use the open door and turn off ignition methods. And that's how we can develop a very simple abstract class and define it in Kotlin.